All right, so on page 45 for academic, we are going to do a few more alterations. On page 45 at the top, guys, we are not going to transform the greatest integer function by a stretch or a shrink. So if you notice there's a -2 right there, that is going to be omitted for academic. However, I do want to practice graphing the greatest integer function with you guys one more time. So we are going to go ahead and graph the parent function right here. And remember, when we write it in parent function form, guys, we do use function notation. So let's go ahead and practice graphing this one more time right here. So remember, to graph the greatest integer function, we always start at the origin, just like every other parent function, it always starts at the origin. But now remember, everything gets pushed down to the lowest integer, which means this has to be an open circle because everything gets pushed down. So that's going to be my first step. Remember, it's also known as the step function. And then, of course, every step above it is going to start right where the open circle leaves off. There's an open circle, so it gets filled in above it. So let's go ahead and just round off these steps here. We're going to go in both directions. And then that's going to just be a little review for the greatest integer function. I am not going to ask you to ever graph a stretch or a shrink in academic for this. Okay, so let's move on because I am going to ask you to do all of these transformations for absolute value. So look at the bottom of your page. And there are a lot of transformations happening in that equation. Hold on just a moment. Let me take roll real quick, guys. While you're waiting on me, if you just want to graph the parent function on the graph on the left side, you can go ahead and do that. We're going to graph that parent function over there on that graph on the left. All right, absolute value parent function, right here. So remember, everything starts at the vertex for the parent or the origin for the parent function. And remember, your absolute value is a one-to-one relationship. And it is always positive. So even if I go to the left, the output is still going to be 1 up. Don't forget to draw arrows, and don't forget to extend it to the edge of the picture. So there's your parent function. Now let's talk about the transformation. There's a lot going on here. What do you guys notice? Very good. Good. And let's just write VR for vertical reflection. Guys, we're going to abbreviate big time on these transformations. And yes, there is a vertical stretch by a factor of what? Good. Remember, it's just the positive value. We already addressed what the negative did right here. Good job. There's 2 more transformations. What else? I'm sorry, right? Yes. 3 to the right, and I'm just going to draw a right arrow. 1 more, guys. What is it? 4 up. Good job. Okay, so to do this, we're always going to plot HK. HK is going to be +3, +4, and then we use our movement chart. All right, so let's go ahead and plot +3, +4. And then, guys, look at the stretch or shrink. This is on the outside. This is away from the X group, not touching the X group at all, which means your movement chart over here, this is the movement chart for the parent function for the absolute value. Since that -2 is nowhere near the x's, you're going to take that -2 and multiply this column. So on my vertex, guys, when I go one place to the right, where do I go after that? What's 1 times -2? 2 down, good. What if I go 2 places to the left? Where am I going? Perfect. Let's go ahead and graph that. Good job. So remember, it's going to be to the right 1, down 2, to the left 1, down 2. But remember, when you go back to the vertex and you go 2 places away, you're going to be going 4 places down in each direction. So your transformation graph is going to look like this. Any questions on that?